Hello, students. And a question from a student on the homework from section 6.3, and it was question number 17, or questions like that. These are questions that involve negative exponents. So let's take a look at question 17. I will jot in a little bit of white space here, and off we go. So if we are interested in writing these in simplest form using positive exponents only, I think it's good to remember what is a negative exponent. So just a brief refresher, if I had the number 3 and I raise it to the second power, excuse me, we're kind of thinking of 3 multiplied by itself 2 times. So the exponent, in this case a 2, represents kind of this repeated multiplication. Okay, if you think about that, that would be a positive exponent. So 3 to the first power would be 3 kind of multiplied by itself 1 time. But if you also look, there is a connection here. 3 to the 0 power has to be 1. Oh, and this would be 3. Sorry about that. So we get 9 goes to 3, goes to 1. We get a beautiful geometric sequence because we're basically dividing by 3 each time. So the next thing would be 3 to the minus 1, which would be, if I divide by 3, would get me 1/3, and 3 to the minus 2 would be 1/9. But I want to connect the idea of these first two because I think it's very helpful. When you think of an exponent being positive, we can think of it as like repeated multiplication. When you think of it with a negative exponent, you should and maybe could think about it as repeated division. So dividing by 3, then dividing by 3 again. So what that would mean is I would start with the number 1, and then I would divide by 3, and then I would take that and divide by 3 again. That's repeating the division twice. However, when you divide a fraction by a number, you end up with, if you choose to multiply by the reciprocal, something that looks like this, which is the same thing as 1/3 squared. So what I want you to notice is a negative exponent can be rewritten as a positive exponent by thinking of inverting the operation. Instead of repeated multiplication, it's division. And what is division other than multiplying by the reciprocal? So that is exactly what's happening here. So if you had a question like question A, or part A, and you had 1/3 and it was raised to the negative 1 power, we could rewrite that to the positive 1 power by thinking of doing division with 1/3. And if I'm dividing by 1/3, it's the same as multiplying by 3/1. Okay. If you want to take a more algebraic approach, this way is a conceptual approach. The algebraic approach would be 1/3 raised to the negative 1 is equal to 1/1/3 to the positive 1. So a negative exponent becomes kind of in the denominator. This is more of an algebraic approach. But notice you're going to get to the exact same place because you have 1 divided by 1/3. And 1 divided by 1/3 becomes the same thing as 1 multiplied by 3/1, which is 3. And that matches exactly what we have over here. So when you see a negative exponent, you can think about replacing it with something that's equivalent, or you can think about kind of just rewriting it as in the other side. So sometimes there's a mnemonic, if you cross the line, you change the sign. And there's so many conditions on that to make it work, but I know some people like that catchy little jingle. So there you go. So if I was doing part B and I had a to the minus 3 and I had a to the 1, personally, I would rewrite this by using they're the same base. So I subtract the exponents. That's what I would do personally as my first step, because that way I'm left with a single expression. And then just like we did up here, to the negative power becomes 1 over to the positive power. Now you could have also written this, and this would be perfectly acceptable, as 1 over a to the positive 4th power. So that matches up with the method that I showed right here. These are exactly the same. And all it says is simplest form using the positive exponents. Both of these are the exact same form. So either one of those would be perfectly acceptable on an exam. So again, I think that's the idea for all of these. I've done A and B. From here on, yes, you may have to multiply exponents, but then subtract because it's just division with exponents. Okay. All right, hopefully that gives you the idea. Two different approaches. I hope one of them works for you. And again, for this particular case, that was the only question the student had asked. So there you go. Off you go, everybody.